I want to start with number 39 that was my challenge to you yesterday. Okay, so here is the problem. 1 over x plus 1 over y equals 8, and 3 over x minus 5 over y equals 0. Now, there is a big hint at the bottom that said if you set u equal to 1 over x, and we're going to set v equal to 1 over y. Okay? Then you can substitute them in to make it a lot easier to solve. So if I have 1 over x, that's going to be u plus 1 over y. V is equal to 8. And then if I do the same thing to the bottom, this is kind of like writing it as 3 times 1 over x. So that would be 3u minus 5 times, whoops, in the wrong spot, minus 5 times 1 over y. So that's minus 5v is equal to 0. Now I can solve normally, make it a lot easier without dealing with fractions. And so, should we multiply the top one by 3 or by 5? Somebody make a choice. Alex. All right. So if I multiply by 5, I'm going to get 5u plus 5v is equal to 40. And then my 5's cancel, and so I get 8u is equal to 40. And so u is equal to 5. Okay? Now, if I put 5 back into my first equation, I'm going to say that v is equal to 3. Okay? Now, that tells me what u and v is. It doesn't tell me what my x and y are. So what I have to do is substitute that back in and say, hey, 5 is equal to 1 over x, and 3 is equal to 1 over y. And how do I get x by itself? Is everybody with me on that so far? How do I want to get x? You can think of it two ways. You could either cross multiply, and so 5x is equal to 1, and then divide by 5, so x is going to be 1/5, or multiply both sides by y, you're going to get the same answer. So, and y is going to be 1/3. Good? Anybody know what the name of that process or procedure or how you do that's called? It's called U substitution. And because you're substituting u in for something ugly to make it easier to solve, and it is a huge calculus method. In fact, that's what they're learning right now in, I think, AB. Good? Come on, that wasn't hard.
Well, you made it seem not hard, but when I was sitting here looking at my paper, I felt like an idiot.
Oh, not an idiot. But the hardest part is remembering and thinking about, oh, hey, I can substitute this easy number in, and not getting wrapped up in this part. That's the beautiful thing about math. You can substitute stuff in to make it easier. You can always do that. Oh, good.
My snowman fell.
All right. So today we're going to do word problems because we love word problems. So,
Miss Mara, are there any more donuts in that box?
There is a cake donut. You may have it if you want.
I don't like it.
Probably why it's still in there. Hope so.
That made me so sad. The only, I knew there was gonna be a donut I like, but the only ones I like are these.
Okay. System of equation word problems. I'm going to, I don't want to say guarantee, but I would bet that, okay.
It was in my lap.
I would bet that you will see at least one or two of these on the ACT. Okay? They always have word problems and they always do system of equations, at least one or two. So we're going to do a couple of them together and I'm going to turn you loose. So when you're doing word problems, what's the hardest part about word problems?
Getting rid of stuff you don't really need.
Getting rid of the stuff you don't need and writing it into the equation, right? So, easiest way is to define your variable. That's the best way to do first. So I'm going to say that x is my first number and y is my second number, because then I know what I'm talking about. All right? And I want to find the value of the two numbers if their sum is 12. That's a big important one. And the difference is 4. What's sum mean?
Adding.
There you go. So that means x plus y is equal to 12. And then x minus y equals 4. I thought I'd throw you a softball to let's get us brain warmed up. And not only is the setup easy, but it's all simplified already, so all I have to do is cancel my y's, and so that makes x 8. And when I put it back into the equation, I find that y is 4. Okay? So let's skip to number 3. What? Oh, his light up pen? I love it. Okay, so I'm flying to something, how do you pronounce that? Kampala? With a tailwind, the plane averaged 158 kilometers per hour. What's it mean to have a tailwind?
Is it like pushing you forward?
Yeah, tailwind is the wind that as you're flying somewhere, it helps push you. If you're going against the tailwind, it slows you down. Okay, it's kind of like the current in air. All right? On the return trip, the plane only averaged 112 kilometers per hour flying back into the same wind. So we want to find the speed of the wind and the speed of the plane in still air. All right, so if I set my variables, and I'm just going to say P is my plane in still air. All right, and we're going to say that T is my tailwind, which is basically the speed of the wind. I just like tailwind. It sounds better than speed of wind. Okay, so when I'm flying to that city, I'm in the plane, and I'm adding my tailwinds because it helps me and it pushes me forward. So on my way back, what equation can I set up? Say that again? Yeah, I'm going to say the plain and still, and I'm going to subtract that tailwind because the tailwind's not helping me. It's actually pushing against me. Good? Alright, then my t's cancel. And so I get 2p is equal to, let's see, 270. And so my plane speed is going to be 135. That's kind of slow for a plane, isn't it? I don't know. That's a good question. And the speed of the wind then, so I subtract 135, I'm going to have 23. Yeah, it'd be kilometers. All right. How do you feel about number 4?
Looks long.
It looks long.
Actually, pretty nice.
Sure.
I'm so
All right. Let's do number 4 together. The school Stefan goes to, and this is one that it does always seem to be on there, or something along this line. Okay, they're selling tickets to the choral performance. The first day of ticket sales, we sold 3 senior citizen tickets and a child ticket for a total of 38. Okay, right there, that's an equation. All right, so the school took in $52 on the second day by selling this many tickets. There's my second equation. All right, so I want the price of the senior citizen ticket and the price of the child. So let's make S be our senior ticket price. C can be my child price. So what do you want to do for my first equation? I got 3 senior citizen tickets and 1 child ticket for a total of 38.
So it'll be 3s plus 1c equals 38.
Yep, exactly. 3s plus c equals 38. See? May look ugly, but it's easy as pie. All right. My second one's going to be 3s plus 2c equals 52. Good? Do we need to solve it? Yes. What's the first step I'm going to do?
Like add them both way.
If I add together, I'm going to get 6s plus 3c. I want to get rid of one of them. So since they're both the same side, I got to subtract everything or flip the sign on anything, whichever way you want to think about it. Then my s's cancel, and I get a negative c is equal to negative, is that 14? So a kids is 14. And then if I put that back into the equation, I can find that the senior citizens are 8. And there's something wrong. Shouldn't the kids be less money than the adults?
But like senior citizens always get discounts.
True. They're on a fixed budget. I'm sorry. It's true. They're all retired. They don't
If I
work.
had $1 for every time someone walked in Panera and asked for the senior citizen discount, I wouldn't have to work there anymore.
That's craziness.
And we don't even have one, so.
That's really craziness. I can't believe they don't. Alrighty. We'll skip 5. Number 6 is going to be the same as number 3. The only difference is that you're going to want to use the rate times time is equal to distance equation formula to set it up. You remember that one?
Equals what?
Your rate
What's decent?
distance
Oh.
times the time is equal to the distance. Okay, and then the rest on the back are pretty much the same. So, here's the game plan.